I'm Anil Kumar, and in this video we are going to discuss a very difficult question on solving trigonometric ratios. The question here is, solve tan of 90 degrees minus 2 theta equals to 1.6443, where theta is between 0 to 360 degrees to the nearest degree. I'd like you to pause the video, answer this question, and then look into my suggestion. It is probably one of the most difficult questions to answer in these set of videos. Now here, what you notice is that we are interested in tan of 90 degrees minus 2 theta. But what we are given here is a domain for theta, and theta is between 0 to 360 degrees. So step number 1 in such questions is identify the domain, right? So identify domain. So that is first step. Now how do we do that? So for that, what we really do is, our domain given to us is theta, which is greater than equal to 0 degrees but less than equals to 360 degrees. This is what is given to us. What we need is 90 degrees minus 2 theta. What is the domain for this 90 degrees minus 2 theta? How do we get that? Now steps involved are, first you multiply this by minus 2. As soon as you multiply by minus 2, these inequalities will also change. So we'll change the inequalities since we know we are multiplying by minus 2. That mistake we should not do, right? So minus 2 times 0 is 0, so you get 0 degrees. Here we get minus 2 theta. Do you see that? Minus 2 means minus 720 degrees. So now minus 2 theta should be greater than minus 720 and less than 0. Now we need to add 90 degrees. So we'll add 90 degrees in all the three terms. That is how you should be solving inequalities, right? So we get 90 degrees. So this is by adding 90 degrees. And when you add 90 degrees here, you get 90 degrees minus 2 theta greater than equals to, you have to do 90 degrees. So what you're doing is you're adding plus 90 degrees and then minus 720 degrees. Do you see that? So let's do our maths. So we'll do 90 degrees minus 720. What do we get? 90 minus 720 gives you minus 630, right? So we added 90 to each. So now the expression is 90 degrees is greater than 90 degrees minus 2 theta, which is greater than equals to minus 630 degrees, right? I hope these steps are absolutely clear. So whenever you have this kind of a question, first identify what should be the domain for the transformed kind of a angle given to you, right? Now we will kind of find the value of the expression. So next we will say, let's do tan of. So I'll write tan of A for all this for the time being, or you would say tan of 90 degrees minus 2 theta is equals to 1.6443, right? So let us first find the basic angle. So we say this angle, right? So let us call this angle. So there are many answers. You should remember that. There are many answers. Tan is positive in quadrant 1 and 3. So there are more than one answer. We have to find all possible answers within this domain. Okay. So what we can do here is, let us find the acute angle. So we'll write this as tan of beta, some acute angle, equals to 1.6443, and we say beta equals to tan inverse of 1.6443, right? And let us see how much it is using our calculator. So we have a second function, tan inverse of 1.6443 equals to 58.69, and we need to nearest degree. So we get this as equals to 58.69. So I'm rounding this to nearest degree. So we'll do 59 degrees. Do you get the point? So what we get here is acute angle of 59 degrees. I hope till now all the steps are clear. Now let's look into it. For tan, what is true? Tan has the time period of 180 degrees, right? And tan is positive in quadrant 1 and in quadrant 3. And now what we found was angle beta is 59 degrees, right? Now we could get 59 degrees as one of the solutions, and the other solution for us is this much. So every time you add, that means plus 180 degrees, right? So every time you add 180 degrees, you land up for the solution, right, in these quadrants. So all additions by 180 degrees should give you possible values of the angle theta, right? Do you understand? So that is what we are kind of thinking, right? So what we have here is that the first angle for us is, so we can write what is 90 minus 2 theta equals to. So we say 90 minus 2 theta is equals to 59 degrees. That is the first answer. The second answer will be, we could always rearrange and find theta, right? So the second answer will be 59 degrees plus 180. Remember, 59 is not in our domain, correct? So that is not the answer which we are looking for. Oh, it is in our domain. It is in our domain since it is less than 90 degrees. So it is in our domain. To get rest of the answers, what are we going to do? We are going to take away 180. So basically, in this particular case, we got 59. Since we are looking for negative numbers, we have to go in the reverse direction, right? So we have to take away 90. So let me redraw this, okay? So let me redraw this. So what we figure out now is we have minus. That is the condition, correct? So this is the condition for us. We have one answer, and that is the correct answer for us. So we have one answer here, 59, and then these are the answers. So the first answer is 59, but the rest should be negative, right? So we'll go and take away 180 degrees. Get this one, then we'll take away, we'll go like this and take away further 180 degree and follow this process to get all the possible answers, correct? So let's do it one by one. So what we are saying is, this is our first answer. Then the next answer will be 59 degrees minus 180, right? So which is 59 minus 180 degrees is equals to minus 121. So we get minus 121. Then let's do again. We'll do minus 121 minus 180 degrees. So we'll again take away 180. We get minus 301. And now we'll again take away 180 degrees, right? So 180 degrees. So minus 180. We get minus 481. Now let me try to take another 180 degrees from here. Minus 180. I get minus 661. Now 661 is not in our domain, right? So we need to stop here, correct? I hope you understand and appreciate why we stopped here. So our angles are, these are possible angles within the interval from minus 630 to 90 degrees. I hope that point is absolutely clear. Now let us solve for the angle theta, right? So to solve for theta, we can do like this. 90 minus 59 degrees, this is 90 degrees, equals to 2 theta, right? So theta will be equals to this divided by 2, right? So let's find it out. So it is 90 minus 59 equals to 31. So we have 31 divided by 2. So divide by 2 will give us 15.5 degrees. So that becomes the first answer. You get the point. So similarly, we are going to find all different answers. So let me write this as 90 minus 2 theta is equals to minus 121. So to solve for it, we are saying 90 plus 121 is equals to 2 theta. So that is theta is equals to 121 plus 90 divided by 2. 105. So we get 105 and we have to write nearest degree. So we'll write 106. Okay, so 106 degrees. Do you get the point? So likewise, you do for all these values. So 4 values. So this time we'll get 90 plus 301 divided by 2 is equals to theta, right? So we do 90 plus 301, say equal to, and then divide by 2, otherwise you're going to do a mistake. And round this higher, so we said this is 196 degrees. This again, 90 minus 2 theta is equals to minus 481. So we can say 2 theta is equals to, we'll bring it here, 90 plus 481. So let me add this now. 481 plus 90 equals to, I'm just showing you different ways of doing the same thing. So theta equals to 571 divided by 2. So now we'll divide this by 2 and we get 285.5. Okay, let me write this, and approximates to 286, right? So 286 degrees. So that is how you are going to write all your answers. So let me now write down all our answers. So our answers are, starting from the very first one, which is 15.5 rounded to 16 degrees, right? So it's 16 degrees. Then we have the other one, which is 106 degrees, and 196 degrees, and the last one is 286 degrees, correct? 286 degrees. So these are the 4 solutions for the given question. You can see all of them are within 0 to 360 degrees. Do you see that? And how did we get it? We did got it with this transformation. So this video is extremely important for you to understand how to get all possible solutions in a given domain. I hope you understand and appreciate it. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.